All right. Thanks for coming to the YouTube channel to get some help on your homework. I hope that I can answer well, just at least get you started on your work and by answering a few questions that you might have. Today we worked on reflections on a coordinate plane. Again, we've done this at the beginning of the year. Just wanted to go back and touch up on some things, help you remember what's going on, because at the beginning of the year was a while ago. So we know that a reflection is what we used to call a flip, right? And when we reflect an image, we reflect it over a line of symmetry. Like the image of this flamingo here, it's reflected on this line, uh, and so it brings the image down here below, and it's the opposite of what's going on. Oftentimes we reflect over the y or the x-axis. Here's an example of reflecting over the y-axis. And one way to draw a reflection whenever it's graphed would be just to count the number of spaces each point is away from the line of reflection. So this J is 1 point away, so we would count over 1, and the new point would be J prime. And then K is 1, 2, 3, 4, so 1, 2, 3, 4 over, and that would be K prime. And then L is 1, 2, 1, 2, L prime. Right? And then just connect the dots, and you have your image. Right, a reflected image of your original figure right there, right, just like they've shown down here at the bottom. And we did show that in class, so I don't think many people have a hard time with this part. In fact, reflection is one of actually the easier ones that we go over. But we did say that they don't always give us a graph. Here they do give us a graph, but they want to show us where these points are, negative 3, 4. So negative 3, 4, that's where P is. Q is at 4, 2, go to 4 and up 2, and R is at negative 1, 1, right there. And they show us that if we're going to reflect over the x-axis, right, we're going to bring this image down over onto this side of the x-axis. All we really need to do is change the y-coordinates to the opposite. Now, let me say that again. When we reflect over the x-axis, we're going to change the y-coordinates to the opposite. Right? And the same is true when we reflect over the y-axis. If we reflect over the y-axis, we're going to change the x-coordinates to the opposite. Right? So that's a really easy thing to remember. So, you know, this lesson really isn't all that hard. There's not a whole lot to it. There's not a whole lot to remember. But as you can see here, here's our regular figure, and we see it's being reflected over the y-axis. And what's happened is all of the x-coordinates have gone to the opposite. This was negative 4, now it's 4. It was negative 2, now it's 2. There is no opposite of 0. It would just stay right there where it was because it's on the line of reflection. And this was negative 3 and it became 3. The y-coordinates all stay the same. They're all exactly where they were. Right? The only thing that changes was the x-coordinates, and they change to the opposite. So again, let me say that. When we reflect over the y-axis, all of the x-coordinates go to the opposite. When we reflect over the x-axis, all of the y-coordinates go to the opposite. So we did this example in class to show you that. And there really isn't much more to it. You can use lines of reflection to help copy images or complete the images. Okay, so here's just some more information about that. And again, it'd be smart you can pause this video at any time, take notes, help work through some of your problems as we're going through. All right. On your homework last night, you know, I don't think many people have many problems with with images like 1, 2, or these problems like 1, 2, 3, and 4, because it's pretty easy just to transfer that over onto the other side. We're just counting how many spaces it is away from the line of reflection. Now, the ones that people seem to have trouble with is when we come to 5 and 6, right? Because it's a diagonal line of reflection. So you start thinking, well, how many is it away? And what I've actually seen some people do is they'll count either vertically or horizontally over, t is 1, 2 away, and they'll go 1, 2, and they'll put t over here. But you see, that's just not going to work, right? What you should be doing is thinking, how can I get this over this line over onto the side? It's like we fold the paper right along this line. And what would it look like if this image was over here? So this time, since we have a diagonal line, we're going to count the diagonal spaces, right? So here is t, and it's one diagonal space to the line of reflection, so we're going to count one diagonal space over, right? And that would be t prime. U is 1, 2, so 1, 2. We keep it right there, that's U prime. V is 1, 2, 3, so 1, 2, 3. Oh, this always happens there. And that's V prime. X is 1, so X prime, and then W 1, 2, 3 again, 1, 2, 3. Right, and so there is our reflected image. And it makes sense. We can look at this and say, yeah, this does make sense, because here t to u is 2 spaces, t to u prime, t prime to u prime is 2 spaces. Right? So we can actually look at it and say, yeah, that's the way it's supposed to be. This one, same thing, right? Except for now we're counting 1.5 spaces away. So you count 1.5, 1/2, and 1. So that would be D prime. Okay, 1 space, 1 space, and so on. You see how that works. I lost my, oh, there it is. Make sure it stays. All right. These are the same thing. It says it wants you to graph it and then reflect it. What I'd really rather you do, I'm sorry, graph it, right, and then graph the reflection, right. What I'd really like you to do first would be to take the A, B, and C and put the ordered pairs here, and then change it. When it says it's reflected over the x-axis, I'd really like you to go ahead and write the new coordinates, right? Find the coordinates. I want you to find the coordinates first, right? Find the coordinates, and then you can graph the reflection. Down here at the bottom, people seem to make a little bit of a big deal out of this. This is not hard at all. It says the coordinates of a point and its image after reflection are given. Describe the reflection as over the x-axis or the y-axis. So what we're just doing is we're writing, was this flipped over the x-axis or the y-axis? We can look at the middle one here, right, and we see, okay, if it were flipped over the x-axis, the y-coordinates would be the opposite. And if it were flipped over the y-axis, the x-coordinates would be the opposite. So I look at my x-coordinates just because they're first here, -3, -3. Right? They're the same. So it must not have been flipped over the y-axis. Right? But when we look at this, our y-coordinates are opposite. So this one was flipped over the x-axis. So you just say, describe the reflection as being over the x-axis or y-axis. So we just write x-axis. Right? There's no big deal here. Describe the reflection. Was it over the x or was it over the y? Now, on the back, most of these are actually pretty easy. And honestly, I ran into a little bit of a problem here with 6. Because when I read that, I just kind of looked and said, I wonder what this is supposed to be. And so I meant to go and look and see, just make sure, really, what they wanted the answer to be. I think I know what it's supposed to be, but I wanted to make sure what they were asking here, because it is a little bit confusing. So I meant to start this before, but let me just pause for a moment. All right, see, you never knew I was gone. Yeah, exactly what I thought was going on with this problem. They actually want you to flip it twice. Okay, do the reflection twice. It says use the information from exercise 5. Suppose that a third building, wait, I guess we have to go over here, right? A corporate plaza is to be built around a small lake. Building 1 has already been built. Suppose that there are axes going through the lake as shown. Show where building 2 should be built if it will be a reflection of building 1 across the y-axis followed by a reflection across the x-axis. So what I would do to think about that, if it's going to be reflected over the y-axis and then the x-axis, right? I'm going to use a pencil. I'm going to use very light markings, right? And I'm going to count the lines to the line of reflection. So over the y first. So 1, 2, 1, 2, and I'm just going to kind of draw this figure. 1, 2, 3, 4. You know, so it goes to there. And then this would be here, 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 right? And so just going to very lightly draw where that goes. All right, and that's my that's my y-axis reflection. So then we're going to put it where it's supposed to go if it's reflected over the x-axis after that. So it would come down 1, 2, 1, 2, 1, 2, 1, 2, and then one in the corner there. This would come all the way down here. We'd have that and that. So our actual building would line up right here. Right? This is where building 4 would be. Right? And then we can erase our light pencil marks. And we notice that it's like it's been folded right along there. Well, actually, not. It's actually not like that. Because this side is now down there. It's not, it wouldn't be up here. Well, anyway, you know what I'm talking about. Maybe not. Ask me a question about it. See, this is what I'm talking about. A little silly thing. I want you to tell me about this. Right? Say, Mr. Reeser, that was my favorite part. All right, maybe not that, but all right. So let's look at this other one. Moving on. Use the information from exercise 5. Suppose that a third building is to be built as shown. So there's building 3. To complete the business park, show where a fourth building should be built if it's a reflection of building 3 across the x and y axis. So first we're going to go across the x-axis. We're going to bring it down here and just lightly pencil in that the building would be 1, 2, 3, 1, 2, 3. And that makes sense. There's 2 spaces there. So there's 2 spaces here. Right, and then we come here, it comes down, and it goes over. Right, and we can count these. 1, 2, 3, 4. 1, 2, 3, 4. Right, from here, 1, 2, 3, 4. 1, 2, 3, 4. Some of you may not need to do that, you know, but some of you just really aren't spatial, so making that reflected image is a little bit more difficult. All right, and then we're going to reflect it over the y-axis. So 1, 1, okay, and that would go there. Of course, this would go 1, 2, 3, 4. So 1, 2, 3, 4. Go away. Oh, great. Perfect. So 1, 2, 3, 4. 1, 2, 3, 4. All right. What's it? 1, 2, 3, 4. 1, 2, 3, 4. There. Right. No, no. 1, 2, 3. 1, 2, 3. So here's our new building. Do it in purple. Right here. Erase the others. Right, and this would be building 4. Right, so everything else is similar to that. Like this star over here, don't try to just draw what it would look like. Actually count. 1, 2, 1, 2. Right? If it is 1, 2, 3, 1, 2, 3. Right? Put where all the points are supposed to go. 1, 1. Right? 1, 1. Then you can just draw straight lines to complete that. Right? Alright, well, have fun with your homework. Yeah, right. This one was actually a little bit longer, so if you watched it all the way through, congratulations.